All right, let's see. So class. Okay. Anyway, you gotta be fancy with it because if I go class, you gotta say yes. If I say class, class, you say.
I got a reputation around here.
For what?
No, I'm just being mysterious in my dark. Can't have me doing that. Yeah, you see the dread?
How's that song go? Whip your hair back and forth. Whip your hair. Yeah. Anyway, yeah. Anyway, all right. So we're gonna do a little bit of math here, just a little bit. So I have, I think, 2 examples to go through, and then I'm gonna let you guys work on the assignments. So we're gonna actually do this, and we're gonna do substitution for this. So integration of tan. So this is something that you can always know what the integration of tan is. I'm going to show you how it works. First, what does tan represent? Sine over cosine. Right, Anthony? Okay, sine over cosine. So I'm going to rewrite. And I'm going to do a substitution. Example 6. Okay, so right here, I'm going to do substitution, but I'm going to call my u. I'm going to say u is cosine x. So my du, what's the derivative of cosine? Negative sine. Now, remember, we're supposed to be replacing. So I'm going to look carefully at what it is I have and what I'm going to replace. So right here, I have to replace this. Okay. Yeah, hold on. Because cosine is just going to be u. So this goes away. All that's circled is going to go away with this. So right here. So I'm going to change this. So now I'm replacing sine x dx with a negative du. Are you okay with that, Blade? Yeah, I moved the negative to the other side. All right, so now I'm going to rewrite my problem. So I'm going to have integration, so negative 1 over u du. Wow, that cleaned up a lot, didn't it? Yes? Okay. Now, what is the integration of 1 over u? ln. So now I'm going to have negative ln of absolute value of u plus c. Now what is u? Cosine. So now I can change this so I can say negative ln of absolute value of cosine x plus c. Now, along with that, I can also rewrite that answer. So that answer is correct. Can I change anything with that negative? There's a rule with this. What do I do with that negative? Where can I move it? Onto the cosine, right? So it's going to be ln and this is to the negative 1 power. It's not the arc.
So that what happens to ln then? If you move it to the inside, it just goes into the top?
Yeah, it goes as the exponent here.
Okay.
Goes to the exponent. So
So it
just for the sake of, I could rewrite it.
So it works for any number, right?
Yeah, with all the LMs. So I could rewrite it like this. Would that be better to write it like that?
No, yeah, I was just asking how you even know this. Like, that's how it works. The inside. Did we actually? Oh.
Okay, but yeah, you guys agree, right?
Yeah.
But I don't want that negative exponent.
So you just.
Turns into 1 over cosine, right? Well, what is 1 over cosine? Secant, very good. So I'm going to have ln absolute value of secant x plus c. So I have correct answers here and here. You could use either.
Wouldn't it be easy to just do the first one?
If you're doing the math, I would stop right there.
Yeah, because I mean, you have a chance of getting it wrong too, huh?
Yeah. So if I'm doing the math, I would stop at this first one. But since right now, at this current moment in time, I'm going to say, hey, what is the integration of tangent x? You would say, you could say ln of secant x plus c, right? So you could actually use that, and that was one of the things I gave you on like slide 2, where there is a whole bunch of integration rules that are already there. And this is just proving that how it worked. Now, this one right here is a interesting one because it doesn't work out regularly. Anthony, what do you think I should call my u?
The square root of 4 minus x.
You have minus x or plus? Okay, so you say the square root of that? Remember, we have to think of it.
It's the inside.
Just the inside, right? Like I would do a chain rule.
4 plus x.
So I'm going to say u is 4 plus x. So du is 1 what? 1 dx. But wait, does that take care of and remove all my x's? I have an x on the outside, right? What can I replace that x with? Everything on the board is true right now. What can I replace that x with? Think creatively.
X squared. Or no. Square root of x squared.
U minus 4? Cheater.
Oh.
Why would it be u minus 4?
Because then u would just be equal to x.
Isn't this right here a true statement? So if that's a true statement, I could also say subtract 4 from both sides, so I could say that x is equal to u minus 4. And because this was a true statement here, this is also a true statement. So now when I do my integration, I no longer have any x's, do I? I don't have any x's, they're all u's. So let's rewrite this. If I rewrite this, I'm going to have integration du dx, so there's no real substituting for that. This is going to be u to the 1/2 times x is going to replace with u minus 4. Du. So I'm going to do a little bit of distribution here to make my integration a lot easier. So I can distribute this now. So that's going to be u to the 3/2 minus 4u 1/2 Did I lose anyone on that? All I did is distribute the u to the 1/2. Okay, so let's take the integration now. When I integrate this, I'm going to start with my exponent first. So it's going to be u to the 5/2. Very good. Times 2 over 5 minus u to the times 2 over 3, right? Times 2 over 3. So that's going to give me 8 over 3. And I get plus c. And what do I do now? Let's put it all back. So 2x plus 4, or 4 plus x, sorry. There we go. Yes, no, maybe. You guys feel good about that? Not too crazy, right, Anthony? Now, I like this one. Example 8. Because you got to get cray-cray with this one. Now, look at them closely. Both of these are going to have the same step to do. Look at them closely. What do they kind of look like? Well, one of the arcs, right? One of the arcs. So now, from my arcs, okay, they both look like it, don't they? So you're saying this one looks like secant, but isn't the secant 1 minus? Okay, so let's do this right here. So I'm gonna say all right, so let's go back to here we go. So inside the radical, let's see, we're over here. So we have a couple of them here. 1 minus x squared is arc sine.
Oh, my bad. I don't know how to say secant, my bad.
Yeah, no worries. 1 over 1 plus x squared is tangent. 1 over 1 quantity of x squared minus 1 to the 1/2 is secant, arc secant, right? So the first one we're dealing with looks like this. My arc sine, isn't it? Yes? Okay, so I'm going to go all the way back over there. like that, right? So I gotta try and make it into that. So I'm gonna rewrite this right here. So I'm gonna rewrite it, and because I look at it, I'm like, okay, the 4 is a problem. I don't like the 4. So what I'm gonna do is I'm gonna factor it out. So I'm gonna say that right here, I'm gonna take this 5, 5. Is that the one you gotta get?
So if you factor it out,
So
then it could be written as.
do you see what I did there? Yeah.
It could be written as rad 4 times rad 1.
Yes. So I could rewrite it as rad 4 times 1 minus this right here. I gotta try and rewrite that though. I'm gonna try to rewrite that. That's gonna turn into x over 2 squared. Now, you see what I did there? By taking out that 4, I have now made it into this, right? It's closer. It's almost there. So I'm going to rewrite my problem. And I have integration of like that. But what is that square root of 4? Isn't that just 2? And if I'm able to take it out right there, what else could I do with that if I take it out there? I could bring it outside as 1/2. So I could take that as 1/2, right? Okay, so there's going to be a 1/2 here. And I'm left with this right here, but that's not exactly the same as that, is it? What would I do with that to make it like that? What have we been doing this whole unit? Come on, soldier boy. You! Come on. No. Soldier boy. You. All right, so my u is going to be what?
X over 2.
Yeah, my u is going to be x over 2.
I was gonna say that.
Yeah, see? So we're going to say that u so du is equal to we're taking the derivative.
Yeah, so it'd be x. Bro, you're actually ruining my calculation. Yeah. X would be x squared over.
Integration adds exponents.
Yeah.
Derivative
Oh, here's the derivative.
subtracts, right?
So it'd be x to the -1. Square root of it, right? X to the -1. And
So no. Right here it's x to the 1, right?
yeah.
And so what do you do with it?
X to the 0.
You x is 0, right? So that goes away. So that just becomes
1
times
times the bottom.
1/2.
Yeah.
1/2. What am I missing?
The
Dx, right? All right. So what am I replacing now? I'm now going to replace There we go.
To d, right? Or
1/2 dx.
replacing that with 2 du.
Okay, so it's going to be, so as I rewrite it, it's now going to be integration of 1 over the 1/2 went away, right?
Oh yeah.
1/2 went away because I took that with my dx. And I'm left with just the du, and now I'm left with just that, right? Isn't that exactly the same we had there? Doesn't that match this? And so if that matches, that means that my integration is going to be arc sine of u plus c. And then what is u? Let's put that back. So u was x over 2. So arc sine
Before you move on from the picture,
Okay, it's almost like there's a video of this too. So if you wanted to,
that's like I had to go to the past that I just have right here. So you're the picture too.
okay, you guys feel all right now? Kind of weird, right? So let's go back to this one. What does this one kind of look like? Arc tangent. So let's see. So let me see. That would be integration of 1 over, was it 1 plus x squared dx is arc tangent? Like that? Okay. So I gotta try and make it like that. So what are we gonna do to make it like that? What was the first thing I did on that last one? Okay. So what am I doing here on this one? Getting rid of? Get rid of the 9. Okay, so let's get rid of the 9. So if I get rid of the 9, times quantity of 1 plus 4x squared over 9, right? What can I do with that 9? This 9 right here? Where can that go? Yes, 1 over 9 where? Out front, right? 1 over 9 out front. Let me change it black. So I'm going to have 1 over 9, 1, 1, plus, now, 2x over 3 squared. It's almost there. What do I do now, Blade? Yeah. So I'm going to say 2x over 3 is my u. So my du is 2 over 3 dx. I don't have a 2 over 3, do I? The last one, I had that nice 1/2 that took care of itself, right? But right now, I can't. So I'm going to replace my dx with what? So hold on. Let me dx and dx. I didn't write it down. Sorry. So what do I replace my dx with? If I don't have anything already there, where does it have to go? Remember, this is a true statement here. What you got, Kissnet? Can we move it to the other side? How would I move to the other side? Yeah, multiply by the reciprocal. So this would be 3 over 2 du is equal to dx. Okay, so now the dx is taken care of. And that 2 over 3, or I'm sorry, 3 over 2 could also come out front, right? So all that can come out front. So that's going to leave me with integration. What's out front of my integration? 1 over 9 times 3 over 2, which is going to give me 1 over 6. 1 over 6. And then it's going to give me 1 over 1 plus u squared du. Now does it match my arctangent? Yeah, now it does. Now it matches my arctangent. So I have 1 over 6 times arctangent of u plus c. And now I just pull my u back, or my x back in. So 1 over 6 times arctan of 2 . Is that cray-cray? All right, questions, complaints, conspiracy theories.
Where did the du go? Like that last part?
Right here. So this one?
Yeah.
Okay, what happens when I take the integration? Du goes away, right?
Oh yeah. Okay. Never mind.
Anything else? All right. So right there, you will all make sure you like, share, and subscribe. Hit that notification button, support my channel, buy stuff from my merch store. My merch store just got updated. I got new shirts on there. They're discounted, $12 right now.